Ladies and gentlemen, we will be starting our program within 10 minutes or 5 minutes. Please wait for a while. Ladies and gentlemen, we will be starting in a while. Please wait for some time.
Hey guys, can you see my screen?
Yes, sir.
Yes, sir.
A very
Yeah,
warm welcome to Granol. A very warm welcome to Granol present here. I would
yeah,
like to
hi.
extend my heartiest gratitude to all people joining us today for this Explores, GitHub, and open source workshop. Today's talk would revolve around GitHub, and open source. Before we start the session, let me make a moment and welcome everybody. So, first and foremost, I would like to welcome our honorable speaker of today's session, Ankit Mehta, sir. I would also like to welcome our branch counselor, Dr. Santosha Kumar, sir. I would also like to welcome our participants to today's session. A lively welcome, guys, and happy learning. But before we dive into the talk, here's a format to give you an idea what to expect. We'll take a few minutes to introduce our guest today and tell you a little bit to you their background in history. We'll then start the session, and then in the second half of the time, we'll open the floor to give you an opportunity to ask specific questions that you have. So, okay, so let's get started. Today, we have Ankit Mehta, sir, who is speaker at 4x PyCon, 3x PyPy, PyData Global, JB at Morgan. He is an open source contributor and former Google Summer of Code, GSOC, scholar under Python Software Foundation. With a decade of Python's programming experience and 8+ years of research and industrial experience at Associate JP Morgan, data scientist and product manager, Fuzzy Logics, that is in USA, in machine learning, quantity modeling, data analytics, and visualization. He has developed an expertise in data handling and entire data analytics pipeline comprising injection, exploration, transformation, modeling, and deployment. He's also having a background of Indian Institute of Technology, Kanpur. So we are highly honored to have you with you, sir. We would now request you to take over the session and start with the session. Over to you, sir, please.
Sure. Yeah, can you see my screen?
Yes, sir, it's visible to us.
Yeah, so guys, I have created a Discord channel for this workshop where I'll be sharing the installation instructions and also interacting with you all in terms of small basically interactions. So kindly join this channel. You have all the installation instructions of the softwares that will be required for this workshop in this channel. So just quickly join this channel IEEE CUK and follow this link. There are 66 people on the call, guys. Hurry up, join the channel so that you can follow the instructions so that we can start as soon as possible.
Yes, I joined.
Only 10 people have joined so far. Guys, it will be hard to follow the instructions. Quickly join it.
Please raise your hands. If the one will be joining it, please raise your hands so that I'll be somewhat fine understand it. What's the series.
Yeah, guys, this will be a nice thing. Just raise your hands once you join it on my Microsoft team. So those who have already joined, just go to the channel and install the two softwares that we'll be using. One is GitHub Desktop, and if you already have VS Code, mostly all coders have that. So you can, it is fine. If you don't have it, you can just quickly install it also. But GitHub Desktop is the most important thing that we require for this session. So make sure you install it. We'll be needing it in the second half of the workshop. Okay, so without wasting any further time, I'm starting with the session. So today's session will be based on GitHub, and open source. Yeah, so before we begin with Git and GitHub, let us first start with demystifying the term we all have heard before, that is open source. So to begin with, let's go through the textbook definition of open source. It is something that people can modify and share because its design is publicly accessible. Now, it can be a piece of code, it can be a hardware specification, it can be a design specification, or it can be anything else. When you say something is open source, anyone can look into the specification or the source code, and anyone can use it, tweak it, modify it, and freely share it. So that's the textbook definition of open source. But as open source softwares, open source hardwares, and other open source initiatives have evolved over the decades, so has the definition. Now, it is just not a shareable piece of software, implementation, specification, or framework. Open source is now a broader set of values. It is actually a way of life. And today I'll be talking about open source by throwing some light on my open source journey, which began at a very tender age of 12, just like you folks. So when I got my first computer. So can you guess what was my first open source activity? You can write it on a channel, or you can also unmute yourself and take some guess.
So soccer.
Can you repeat?
It's soccer.
Yeah, that means Sarga means year. Okay, so the thing is, guys, Well, I don't want to disappoint you all, but I'm no Wolf Gupta, the famous Wolf Gupta. Like any other 12-year-old, I just did what everyone else does. I played some awesome games, a lot of them actually arcade games, strategy games, racing games, and many more. So, so the whole point of telling you this exercise is you should not get disheartened if you are not familiar with open source before you entered college. I have been in your shoes. So my actual open source journey started around 2010 in IIT Kanpur, where I learned my first open source lesson, which is open source is about learning, tinkering, and exploring. So when I joined IIT Kanpur, I was quite enthusiastic in regards to programming. So I joined the programming club and undertook a summer project named as Fragile. So this colorful application, it was a desktop application, was built completely using Python, which is an open source programming language. We all know Python right now as it is very popular with the machine learning, but back then it was still gaining some traction and it was not that well known. So so Python was not that famous as it was pre-data science era, and many of the tools like Jupyter Notebook, Scikit-learn, Pandas, which are widely used today, were either not available or were in very early stages of release. And as far as I remember, I was working with Python 2.5. So there was no fancy code editors available for Python like we have now, like PyCharm and all. Those things were not available. You just had a plain old simple ideally, which came pre-packaged, and it had a notepad like syntax highlighting. So it was like a notepad. So while I was building this application, I realized the power of open source. You could use open source packages to build full-fledged UIs, and you could use cross-platform UI libraries like WX Python, TK, which could run on Windows, Mac OS, Linux, and basically also there was an open source game programming framework, Pygame, and 3D rendering library like VPython, and lots of other open source libraries which were part of this open source Python ecosystem. So this was my first experience with the open source ecosystem, and it was quite a good learning experience. I also tinkered around with Unicode keyboards, generating terrains, and also I mentioned, I was fascinated with games. So in games you have these terrains. So these terrains are programmatically generated. So I tinkered around with that, and also these open source softwares allowed me to learn quite a lot. But this journey was not alone. And here came my second learning. That was open source is about having fun, sharing ideas, and teamwork. So I got together with a lot of people who were equally enthusiastic about Python and its capabilities. And they would listen to my ideas, share their own ideas, as the open source culture is all about sharing. So you share your codes with people, they provide you feedback, then you improve your codes. But most importantly, you have to understand that it's not about sitting in a silo working on something. You should have fun with it and you build while you are building something together in a collaborative fashion. And open source, then came my third lesson. The open source taught me that it is not just about learning and having fun, but it is also about teaching and enabling others. So as there is no proprietary licenses involved in open source software compared to softwares like MATLAB, where you have to buy a license for each user, anyone can download and use it. So open source is not just about learning, but also teaching so that they can make so that people can make their life easier and take the software forward. So along these lines, I started teaching Python and other open source softwares to as many people as I can, so that they can go ahead and build something or use it to their in their research projects. So while teaching, there is another important thing that I uncovered in the open source ecosystem. That is, open source is also about embracing diversity and inclusion. So diversity, not just in respect to gender, but also culture, thoughts, and ideas. So give you a very good example. So earlier, the programming culture in my institute, that revolved around the computer science department. So I tried to open it up a bit by including other departments and teach them how they can use open source softwares in their department related research. For example, in mechanical and chemical engineering, they can use open source softwares for fluid mechanics and process engineering. Also, be it any department, the crux of all engineering problems is solving mathematical equations and how they can use open source software to actually solve those problems. So you might have heard that just a few years back, companies like Google started talking about diversity and started its Women Tech Makers program. So we were facing the same issue back in 2011 and took initiatives to mentor and include more women so that they could lead programming projects, and it was quite a success. So another aspect that I want to talk about when it comes to diversity is when you guys enter college. Everyone is like DS Algo, Code Chef, Lead Code, competitive programming, some random DS class, getting into FANG. But open source culture is not about that. It is about treating everyone with respect, fairly and equally. So not everyone loves competitive programming or code optimizations. Some people are more creative and they like front-end development. Some people want to pursue ethical hacking and bug bounty hunting. So I came across tons of open source projects which covered different domains, and I was quite impressed with it. And as an organizer, it was my responsibility to actually let people discover and explore their passion. So I started organizing various competitions apart from competitive programming like web dev, fast development, ethical hacking, reverse engineering. So open source is all about exploring. Basically, you pursue the domains that actually interest you. So, and since my school days, I was fascinated with supercomputers, and you can say it was my high school wish to one day actually run my code on Paran's supercomputer grid. Uh, so when I was in fourth year in my college, I got a chance to get in touch with the director of CDAC and organize the first international high performance computing contest in Asia. So in this contest, the codes were directly submitted from students across the globe, and they were directly run on the Param supercomputing grid with around 1000 plus codes reserved for the event. So while organizing this event, I realized that open source is also about embracing shortcomings and innovating. So, since open source projects are not heavily backed by industries, so back then it was not that backed by industries, and people were also like they were independent developers. They in their free time they used to develop. So there were shortcomings. It was not like the libraries were not fully built or they were not very efficient. But it in open source projects it takes time. So for this event, people had to write codes which could execute in parallel using MPI library in C. Now I was familiar with the Python ecosystem, and till now I was like that, yeah, Python can do everything. But during this contest, I realized that it has its own shortcomings. So the Python ecosystem, open source ecosystem was not that mature enough for parallel programming and high performance computing. So it was not just me, but others across the globe also felt the same, and they started building it and innovating. And today we have some of the most wonderful open source libraries like Dask, Rapids, Numba, which can using which you can easily write high performance codes in Python. So at times open source softwares may be a bit behind your need, but definitely when the community force joins the open source project, they can build truly tremendous stuff. So you have to remember there are shortcomings, but eventually you can also take part and actually improve the open source software. So that's the most important part. You embrace the shortcomings and innovate. So when I did my master's in scientific computing, I was solving these equations, phase change equations in Fortran and published quite some papers. So over the past 4 years, like open source had taught me a lot. And I thought that it was high time that I also contribute something to the open source community. So it was then that I enrolled in GSOC under Python Software Foundation and added my research to the existing Python project, which is SFEPy. So the best part about GSOC was that you get paid to make contributions. Uh, and it is also getting competitive every year. So it is good to actually start a bit early. So if you are familiar with GSOC, actually the 2022 program is actually been announced on Feb, basically in Feb, the first week they announced it. And these people are actually right now accepting mentoring organizations. So actually, if you are interested in making open source contributions and also earn while doing the same, now is the time. You can gear up, reach out, find an activity that interests you, then or an interest where, or a project which interests you. Reach out to the maintainer of the project and see if they are enrolled as a mentor organization in GSOC. They are maintainers are actually quite, they are quite great folks in guiding and mentoring people. So reach out to them. Many projects have their dedicated pages for GSOC. In case there isn't, you can reach out to the organization maintainers and tell them that you are interested, and they will suggest you that okay, they can assign you a first quick issue which you can resolve, and then they can, okay, they can apply, go ahead and tell Google that I want to participate, and then formally you can submit your application under that organization. So now is the right time to actually start with GSOC preparation in case you haven't done so far. And it actually, it's a long process. You need to interact with code maintainers. They will assign you some first simple issues. You will resolve them, resolve those issues. It will give them confidence. Then you will have chats with them. And then basically you can come up with a problem that you want to actually undertake in the Google Summer of Code. And then you can, when your application is submitted and you have a good rapport with the mentor, definitely you will be selected for the program, and then you can go ahead and contribute and also earn while doing the same. So in case you have any questions related to GSOC, now is the time. Let's take a quick 2 minutes break. And if you have any questions, you can unmute me yourself and ask me directly. You can also post in the Discord group. If you want to ask any questions related to GSOC, I will address it as and when I see the question.
So, sir, every year there are different open source softwares participating in this, or this same?
Actually, many software foundations are actually, they participate every year, but also new organizations take part uh, every year. So there are also new organizations which take part. It actually depends on the interest shown by the students. So if a student is very much interested in actually contributing to a open source project, then even if they did not plan to initially take part, they will actually want more people to get involved in their project, and they will gauging your interest and gauging your response to some assigned first issues which are simple. If you resolve it and talk to them, they will be interested to actually go ahead for this GSOC, and they will be ready to mentor you. So in case they are even if they are not enrolling, if they don't say explicitly that they are not participating in GSOC, it is a good idea to actually reach out to them and ask them if they are willing to participate, as you are interested in contributing to the project, and then they can submit their application to Google, and actually you can then participate as a mentor, because the same thing happened with me. So in Python Software Foundation, under that, there are a lot of Python projects. So the project in which I wanted to contribute was actually not planning to participate because it was a very highly specific library which dealt with this modeling, mathematical modeling. So actually, I reached out to him and we communicated. Then we came up with a problem statement, and then he went and told the Python Software Foundation that he wants the project to take part in it. And then the Python Software Foundation forwarded that application to Google Summer of Code. So it happened with me. So there are high chances that if you express your interest, your project maintainer will be willing to actually, even if he did not plan beforehand, he will be willing to actually go ahead and apply as a mentor organization in GSOC.
Okay, okay, sir.
Yeah.
And so for that, is it necessary for we to have, I mean, knowledge in more than one
Yeah,
language?
so it's a very good question. So the thing is that no, that is because each and every project has its own tech stack. Some projects are based on Python, some have the tech stack as JavaScript. So each and every project has their own tech stack. So the most important thing for you to do is actually see the project that basically interests you. So if a project interests you, then you will automatically find time to go through its documentation and go through its tech stack and the initial contributions that initial basically issues that the mentor will assign to you will be simple. It will be a learning issue. It will be like learning on the job kind of thing. You will get familiar, you will interact with him, he will explain you a bit about the code base. Then you can if a specific skill set is required, like a particular language knowledge, you can easily quickly grasp it. That won't be much of an issue, you can do it on the side. But while contributing to a project in the early issues, once you go through the code base, you will get familiar with it, and that's why it's a long process. It's not competitive programming where you have just 3 hours and you have 5 questions and you have to do it. It takes months to actually understand an open source project. So you have to devote the time, and they will expect that, and they are not like the maintainers are not like they will expect you know everything. They will assign you issues. Just keep a good rapport with them, interact with them. If you have doubts, ask them. Invest your time in that project, and you will actually achieve a lot in that process. And if you are not basically you are not uh, skilled enough when you started with that project, eventually you will be. So it will take a month, but then you will know in and out of the project.
Okay, okay, sir.
Yeah. Any other questions, guys? Okay, so let's go ahead. So in case you want to participate in GSOC, make sure you start right now, because the application, they have announced the program. So it will be a good time to actually start looking around for a good open source project that you want to participate for GSOC. So moving ahead. Yeah. So it's not just GSOC. There are also other programs which provide you opportunities to contribute to open source. So a very popular program is this Hacktoberfest, which happens in every October. They give you goodies for contributing to open source. So that is also a good time to start some contributions. So a lot of first issues are marked by open source project maintainers around that time. So Hacktoberfest is also a good time to begin. Then then you have MLH fellowship, which is similar to, basically it is also similar to GSOC, but it has a totally different way of applying. And they are right now they are also fully people are over applying for MLH fellowship. Then there is a season of KD, in case you are interested in contributing to the KD community. And in case you are very good at technical writing and and you are interested in actually documentation, then there is a very good season of docs program that is also hosted by Google. Now this program gives you an opportunity to do technical writing and also earn by doing the same by contributing to open source project documentation. So in case you are interested in technical writing, learning how to write good documentation, then season of docs is also a very good starting point to do the same. And they have also announced their application. So for season of docs, the timeline, they also announced it in the Feb, and the program announcement happened on in 3rd February, and they have started accepting basically you can right now reach out to the organization in case you are interested in contributing to the documentation, and they can also start filling their organizational applications from 23rd February. So in case you are interested in technical writing, this is a good program to actually contribute to the open source community and also earn money for doing the same. So now moving ahead. So when after college, I moved to US and started working in big data analytics firm. I worked across the entire data analytics pipeline, developing a proprietary software. So it was a proprietary software on which I was working firsthand. And I saw how open source was actually crushing it on all fronts. So basically, you can say that for each so each and every analytics step of the analytics pipeline. So like basically you have today you will find a robust open source software for each and every individual component. Like you have pandas for data wrangling. You have TensorFlow for machine learning. You have XGBoost and scikit-learn also for machine learning. These are open source projects. So it was totally crushed, like R and Python ecosystem was totally crushing closed source competitors like MATLAB and SAS to dust. So there is even a state of the art open source. You can see this chart over here. So all these basically toolkits, they are open source. So for data exploration and visualization, ingestion, development, then you have programming languages, platforms. So many of these open source software are actually crushing it. And also there's a state of the art open source software called Apache Airflow, which handles the entire pipeline. So you have to understand that right now open source is becoming a new business model. So many of these companies like S2O.ai and Google are actually open sourcing their products, and they are earning from services, support, and solutions. So it has totally emerged, open source has emerged as the new business model. So you can see many firms are actually starting off as a open source project, and then they offer support they will resolve any issue within 24 hours or 10 hours, even 10 hours. But and only for those support, and they can build you softwares for you using that open source project. So using those solutions and services, they are actually earning money. So it has open source is actually evolving into a new business model. So like TensorFlow, a very good example is TensorFlow. So TensorFlow is open source, right? So you can install it, build models, but when you want to serve those models, a go-to method is actually to upload it in basically Google Cloud. You have TensorFlow serving. So using that, Google actually earns money. That the number of uses of your model to actually for example, click a picture and run the model on that picture using a mobile device will actually be counted towards your quota, and that will be actually the revenue for the Google. So they are open sourcing TensorFlow, but when you are actually deploying the model for the real-time scoring, then they are the service that they are providing for hosting it, the model, and actually enabling you to use it in directly on your mobiles that is earning them the money. So it has become a new business model. So when then I moved on to JP Morgan, so which is one of the largest financial institutions, and they operate in a sector where companies and banks are quite skeptical when it comes to open source software, and they are most reluctant to new technologies because they deal with money, and they are very particular that nothing there should be no risk, no technical risk, no risk at all when it comes to using such software. That's why they are very risk averse, and they have legacy models which are well tested. But in JP Morgan also I witnessed that the entire platform was actually powered by Python. So and many other open source libraries. And then it dawned that open source is everywhere and companies are actually rapidly embracing it. So when I left, so then I left JP Morgan to become an open source developer working on Titus 2. So Titus 2 is basically a Python 3 implementation of the PFA standard. So in this PFA standard, a company develops a model and then exports the model in this PFA format, and that PFA format can be easily deployed on the server. So I was working on this library to enable this part. So it is when I was working on this library, I actually realized that open source is not just about writing codes. It is more about specifications and standards because a specification stays forever and makes the software reproducible. For example, Python has a core group which works on new specifications where they discuss for years on a new feature that they want to introduce. A very good example is actually the match statement that they recently introduced. So they discuss over such specifications, and basically the specifications that they come up with are.
So
Excuse me, sir.
you
You are on
mistakenly
mute.
muted yourself, sir.
Yeah,
Sorry for
where
the
was
interruption,
I?
sir. Actually,
Actually, I did not unmute myself. I don't know why it got unmuted.
Yes, it was just 10 to 15 seconds. You can continue.
Where was I last time?
I mean, here only, sir. Just 10
No,
15
no.
seconds.
Did you all listen about the match statement that I was talking about?
Uh,
Python
yes, sir,
match
yes, sir.
statement.
We listened it, sir.
Okay.
Interesting about new features.
Yeah, yeah.
Python's new mathematics feature.
Yeah. So the match statement. So yeah. So finally, when so people discuss on it, draw up the specification, they how it should behave, what is the need of this feature, and finally, when that specification gets approved, it takes actually less than a month to implement it. But this process is important as when you have that specification, you can go ahead and implement it in any programming language. So this match specification that Python came up with, JavaScript folks saw the utility of it, and they said that why not we will learn from this specifications and we will implement it in JavaScript. So this specification did not help only the Python community, but it also helped the JavaScript community and other programming languages that they want to go ahead and implement that feature. So even the Python software that we use today is actually written in C. But since there is a well-documented specification of Python, anyone can go ahead and implement it in Java, JavaScript, Rust, or any other language. So you have to understand so this is what I learned, that you have to understand a lot of time is actually spent in an open source project in drawing up the specification. What is the goal? How are you going to achieve it? And what are the different ways in which you can achieve it? So that's the reason why it takes such a long time, and that's why it is important to have patience. So that's why you need to have patience when you are working with open source project. It may take months, it may take years. So people are actually many people are actually working on the open source software as a side project. Some are actually doing it in their off time. So you have to understand that it takes years to build a reputable open source software on which people can trust. And you have to understand that there is no money or guarantee. So the work you are doing and your vision is the only motivation you have. And you need to have that patience to not lose your nerve. Also, contributors are spread across time zones with many people working on projects on spare time. So actually the genesis of any open source project, which is a hot topic right now, if you trace the genesis, it will be at least 3 to 5 years in making. So you have to understand it takes a lot of patience. And if you don't have that if you have don't have that faith in developing the standards or specifications, you will tend to abandon the project. So it is very important that you are passionate about the cause and persevere relentlessly. So, and building something is not the end. So it's not just that, okay, you went ahead, you did some code, you built it, you pushed your repository, now it is live, done. No, it's not that it. You have to understand that you do not have funds to put up a marketing campaign on YouTube or Instagram, right? Like other software companies, you cannot put Instagram ads that come use my software. You have to go on ground and spread awareness and tell people about the advantages of your open source software. So that's why you have to go to a lot of conferences. You have to spread awareness, uh, not just about your project, but also any other open source project that you find useful. For example, there is a project called Numba, which I truly believe in. It is revolutionary. So I talked about Numba in a lot of these conferences to make people aware of its advantages. So that is also a way of actually contributing to open source project, because Number team doesn't have that marketing budget to go ahead and tell people about it. So even if you like an open source project, just go ahead and talk about that open source project and spread awareness in conferences. You can put YouTube videos. You can actually go ahead and write Medium articles. Even a tiny drop will make a difference. So you have to understand that there are a lot of different ways in which you can actually contribute. So, and because open source project is about awareness and adoption, until and unless are actually people are using your project, uh, uh, it is your project is actually you won't get that satisfaction until and unless you have people who are actually using your project, actually using it in the production environment. So that will give you the most satisfaction. So make sure that once you build an open source project, you spread awareness and try to get your project adopted by other people by showing them the advantages of your project. So now I want to just take a quick detour and talk about open source ecosystem, which is gaining quite a lot of traction nowadays. So there is a open source ecosystem, Flutter ecosystem. How many of you have heard about this framework Flutter? Just a quick raise of hands. There is Tanmay, there is Tushar. Yeah, Mudit. So, yeah, quite a lot of people have heard about Flutter. So, can someone just unmute himself and share what Flutter is? Anyone who knows about Flutter, just unmute a bit and share what it is.
So free and open source mobile UI framework.
Yeah, exactly. It is an open source UI framework. And the thing is that it is not just for mobile. You can also develop web and desktop applications using the same code base. So Flutter is Google's cross-platform UI toolkit. So it allows fast development, beautiful UIs, native performance, and you have an easy to learn that programming language. And you using a single code base, you can build mobile, web, and desktop applications. And the thing is that it is completely open source. This whole framework. So it launched around May 2017. It took around 4.5 years. It has been around 4.5 years now. And Some of the most popular apps today are built using Flutter are like Dream 11, it is built using Flutter. You have Google Pay, which is built using Flutter. Then you have a lot of smart apps, IoT and smart apps that are built using Flutter, because Flutter has these awesome packages which can allow you via basically features like Wi-Fi, BLE, which is Bluetooth Low Energy, Bluetooth, NFC, beacon. So you have a lot of packages to actually support these cutting edge technologies. So people are using Flutter for building such smart apps. Now let me talk about an app development process. So let's say we want to create an app for a street artist. So we start with gathering requirement. We will draw the frame mockups, UI mockups that okay, this is how the app should look like. So this app will be basically you will have cards uh, in which there will be a picture of the street art, the graffiti on the street, and there will be a location underneath it. So when you click on a card, it will zoom to full screen and you will see the graffiti in the full screen view. So it's a very simple application. So you have material design components. These are the specifications built by Google that, okay, this is how an app bar should look. This is how it should behave, how a bottom app bar should behave or a button should behave. So this is the material design specifications, and Flutter comes pre-packaged with the implementations for these components. So you have these pre-built in Flutter. You can directly go ahead and use an app bar. You can use a bottom bar. You can use anything given in the specification. So, so you can see how open source is more about specification standards and implementation. So Google developed this specification and now they have implementations like they have Android implementations, they have iOS implementations, they have Flutter implementations, Dart implementations. So, uh, so the specification and standards were the basis on which people built those implementations. Now I can directly use some of the component widgets that are provided uh, and I can get something like this. So you can see there are graffiti street arts and the alley in which it is located. So now you can see the issue is that these are not having the proper aspect ratios. The street arts are not in proper aspect ratio. You are so now what you can do is you can go ahead and fit these images in the proper aspect ratio. But in this case, if you do that, you can see there are a lot of white spaces and you actually missing out on a lot of and it is not a good experience. Basically, it's a poor experience because a lot of white spaces are there. So a good solution would be to do something like this, right? So the cards are actually they have their width and height based on the aspect ratio. So since they have a fixed width, the heights will get adjusted and they will be staggered in a staggered view. So this will be a good thing to do. But Flutter does not have this feature pre-packaged. Now the reason why I'm telling about this problem is that open source is about actually not reinventing the wheel. So it is not that now you need to go look into how you can implement it. So a lot of people have developed packages and you can look for those packages. So there are around 20,000 plus packages and every day a lot of people are contributing packages, which is their contribution to the open source Flutter ecosystem. So instead of reinventing the wheel, developing this entire component yourself, you can look for packages. So, so the issue now comes the next issue. Now this pubdev is basically where you search for a package. Now it is text driven and it is really hard to actually look into it. How will you actually find that package, what you are looking for? Until and unless you know the exact term, like I want a staggered grid, you will not be able to find it. So so lot of what people did, they used to post it on Facebook and everywhere else. They used to post that I want something like this. I want my UI to look something like this. How can I do that? How can I do this? So this was a major challenge when it came to Flutter. So what someone came up with was they built a visual discovery platform, which is fluttergems.dev. So in case you are not familiar, just check it out, fluttergems.dev. So fluttergems.dev, what it does, it actually has the entire landscape, a lot like more than around 3000 packages are actually classified based on their functionality, based on the UI. So in that, for example, if you have a package related to QR code barcode, you can easily look into it. Now in our case, the package that we wanted was based on grid. So if you just click on the grid category, you can now quickly see the images, and through images you can take a call. For example, here you can see there is a package called as waterfall underscore flow, which is exactly what we wanted. Now tell me how can anyone imagine that, okay, this is the name of the package that I need. So this was a challenge. So now using the visual discovery platform, you can easily find this package by clicking on grid. So similarly for image, for example, if you want to show something like before and after, you and you don't know that it is there's a package named as before underscore after, then how will you find it? So again, you can check out the image category and you can easily look through visual image that, okay, this is the package that I want. Similar goes for neomorphic UI. So and different ways of loading action buttons. So why am I discussing about Flutter and then I'm talking about Flutter gems? So the thing is, if you remember, I talked about, right, open source is about embracing diversity and inclusion. So it has been my honor, like actually this Flutter Gems was built by a single person, and it was built by the person who actually I mentored long back when I was in college. And this was appreciated quite a lot by even by the group product manager of Dart and Flutter. Like Tim Smith is the biggest guy when it comes to Flutter. So even he appreciated it. So you have to understand that given the right moment, uh, when we embrace diversity and inclusion, actually we are embracing the diversity and of thoughts. So nobody thought about this idea before. Nobody came up with this idea how to the way in which you look at a problem. So these diverse backgrounds actually give you a different perspective when you look at a problem. So this lady, she looked at this entire thing from a different perspective, and because she was mentored at the right time, she was able to build a very big project. So you have to understand, and this was done by a single project. Someone is actually requesting control. So is it by mistake? Tesla Paul?
Yes, sir. You may continue. I think it's by mistake only.
Okay, then I'm denying it. Yeah. Yeah, so you have to understand it that it was just a single person. So you have to understand that even a single person, you can actually make a difference. So no project is too small, no project is too big. If you have the will in open source world, you can actually go ahead and accomplish a lot. So check this project out. It is quite good. And uh, now the next part is open source is about writing good documentation. So it's not just about code. You should also write good documentation so that people can learn from your project and actually go ahead and execute whatever you have built. So it's important to write a good documentation. Treat your README file, the GitHub README file that you have, treat it like your Tinder profile. You want to put your best foot forward, right? When it comes to Tinder profile, treat your README like that when it is an open source project. It can actually make or break the call that if someone wants to use our package or not use the package. Have a well documented API, have lots of examples in form of micro examples, like small examples having exact features that you want to showcase, that okay, this example shows this particular feature instead of a one big example. Have a lot of micro examples that will give, so that people can quickly copy the snippets and they can run your project. So it is very important to have a very good README file. And you have to understand that obviously open source is more than just writing a piece of code. You have to look into all the aspects. So even if you can still see there are a lot of big modern digital infrastructures actually have some random person who has been selflessly and thanklessly maintaining a project way back going 2003. So there are packages, libraries, toolkits, open source that were built by a single person that is actually fueling today's modern digital infrastructure. So so it is, so not just it is about writing a piece of code, it is actually a big responsibility. So it's not just that you go ahead and publish your package. You have to.
Once again, you are muted.
Yeah, it said someone in the meeting muted me. Yeah, please guys don't mute me. Yeah. So for that you have to write a lot of unit tests. You can write unit tests, testing single functions, workflows, and basically methods. Then you can do component testing. Hey guys, someone again muted me. Can the moderator take charge?
Sure, sir. We'll look into it.
Yeah, please take charge. Someone again muted me. Yeah. So you have integration tests where you test a complete software app that is built using your project. So the entire workflow you can do. You have to write tests. So more and more tests you write will give you more and more test coverage. So that test coverage basically shows that, okay, these are the these many lines of codes are actually being covered by the test. And this coverage gives confidence to people that, yeah, if you have a high coverage percentage, like more than 90% coverage, then it shows faith. People have faith in you that, yeah, they can try out your open source project in production as you have tested it well, and you have set up the framework for testing and debugging, and you have this automated pipeline which checks for basically any new commits or any new contribution that is being made. So these are testing is a very important aspect, and automated build and testing can be set up for open source project for free. It is done for free by this Travis CI. You can try out Travis CI. It does it for free. So moving forward. So and also not just testing, but also the release frequency matters a lot. So it's not like you released a software like 3 years back. You should also maintain a good release frequency where every quarter you are going to release. You can test for example, in Python, you test for new versions of Python and see that everything is passing well. So set up a release frequency, jot down that, okay, in this quarter I will add these features, I will do these bug fixes. So make sure you set up a release frequency. It can be quarterly, it can be semi-annually, anything, but have something. And also have this changelog.md file well maintained. So this file actually lists that, okay, in this release, these are the new features that has been added. These there is an change in the existing functionality of these features. Then these are the functions that are or features that are going to be removed soon. So you also put down a deprecation notice, and what are the features that has been actually removed from this release. That way you make a note of that, the bug fixes, and any security updates that you want to relay to your basically users. You also mentioned it in the changelog file. So as a As an open source developer, it is a very good practice to have a release frequency and properly maintain the changelog file, so that whenever a user comes across a new version of your software, he can quickly look into the changelog file and see that okay, there are no major changes in this release, so I need not update my current version of the software that I am using. And the most important part is to become a BDFL. So BDFL is benevolent dictator for life. So you are a dictator because actually you are leading the project, but you have to be benevolent. You have to listen to everyone. You have to set up guidelines, how people can contribute, respond to issues, respond to pull requests that people send that, okay, these are the features that I want to add. You respond to those requests. So you have to be open. It is your project, but you have to understand an open source project is a community project. The more community you involve in your project, that will actually take your project forward. So be benevolent, be open, and basically interact with people and let the community shape the future of your package or software, whatever you are building, which is open source. So finally, I want to conclude that open source. So we saw. So the entire thing we went. It tells us that open source is not just about source codes, softwares, or specification. It is just about you being more open. So when you are more open, you include all aspects into the picture. You become benevolent. You let the community shape your software. You will definitely succeed as an open source software developer. So moving on to the next part. So we will quickly move on to the version control. And before moving to version control, I just want to quickly check if everyone has joined the channel. So so guys who have joined the channel, guys and girls, make sure that you install GitHub Desktop. And if you have Visual Studio Code, it is good. If you don't have Visual Studio Code, make sure you install it or use or have some ID with yourself. So I'll be using Visual Studio Code. That's why I said Visual Studio Code. But in case you have any other ID, it is fine. But do make sure you install the GitHub Desktop one. Okay, so let's move forward. So what is version control? So this is a term which you have to understand that version control is a term that computer software industry did not invent. So it is merely so this software industry has basically adopted the practices that were already well established in industrial manufacturing and design. So where in industrial design and manufacturing, you have each and every component. It is well defined. You have a technical drawing of that component. For example, uh, anything, be it a simple chair, be it a table, you have a drawing, a specification, and there is a spec which specifies the materials and the manufacturing techniques that can be used to build it. So basically in traditional manufacturing and design, they already had this in place, this system to actually maintain versions. So for example, they will come up with a table design. Just wanted to tell the admin that someone again muted me, so it is happening quite frequently. Can someone do something about it? Revoke any permissions?
So we have looked into it. Actually, none of the guests have this permission to mute someone.
I don't know why then again it is being muted time and
Right,
again.
sir. So we are still looking into it. We'll see that it won't happen again.
Sure, sure. No problem.
Sorry to interrupt, but I think you should make us attendees so nobody will have the permission to mute, sir.
Yeah, can someone look into it?
Sure,
How they
thank you
can
so
do that?
much. We'll do it.
Yeah. So in traditional manufacturing and design, you have this specification. You have this technical drawing, there is a specification, and basically you have this, for example, for a simple table, they will have a specification that this is how it should be built. And this is the first version of the table that we are going to build. Then in the next, then after getting some customer feedback, they'll be like your table. So when they will sell the table, it will be like after the customer interaction, they will find out that okay, your table chips quite a lot.
Excuse me, sir.
Yeah.
Are you right now presenting?
And someone, wait a second.
Yes.
Yeah. Yeah. Now is it visible?
Yes, sir. Yes, sir. Now
Yeah.
it's visible.
Yeah. So for example, after selling the table for the first time, customers will come back to you. They will say that your corners are chipping off. The material of your coating is not good. The paint that you provided is not good. So then you will come up with a design version 2 of the table where you will improve the build quality of your table, the polish or the finish of the table, the material for the coating of the table. So there are a lot of things that you can actually. Yes. So a lot of things you can do. So a similar example is basically I want to show you a very simple thing like a coffee lid. So you have this lid in your coffee cup, right? When you go to Starbucks or CCD. So that also over the years has gone through a lot of versions. So you have a base version, people build a new feature on top of that base version, then someone builds another feature on top of it in the second version. So this is all about version control, and it is not a new concept. It has been there for like decades. And the best example is version control 101 that we all are familiar. How many of you have done this thing for your assignments? A quick raise of hands. No one? Okay. So this is something that a lot of people do is like they start with a draft V1, then draft V1, then keeping a copy of the draft, modifying it to a final draft, final version, final new, then they will make some more modifications. So this is the most basic version control that people do, is they try to keep a copy of each and every stage that they think that, okay, this is the stage in which I must keep a copy before I delete a lot or I modify a lot. So this is a very basic version control that we all do. And version control, also known as source control, is actually the practice of tracking and managing changes to software code. So what we know today is for tracking and managing software codes. So the open source projects, you want to track it that okay, these are the changes that went through in this release. This person contributed this change in this release. So you want to track each and every successive version as your software is progressing, so that if there is any malicious commit, you can remove it, or any new feature that you introduced that did not work as well as you expected, or it actually went ahead and broke some previous feature, then you can remove it because you have this version control for your entire software. So the evolution of version control systems has been from first generation version control system. In first generation, there was no networking, there was no internet, no collaboration. In a computer, they had a software which used to just track the file changes locally. Then came the second generation where people thought that there is no collaboration. We want to work as a team. So the code base was actually version in the single place, which was a server. So there was a single server where there was a code base, a single there were, and if that server got compromised, then it was a point of failure. Then forget your code, your software. and users had to always like ask for the latest release from the server before they actually go ahead and commit their change. So so you cannot do it concurrently in your local servers. You have to go to the central server. You have to fetch the latest version, modify, make changes to the file that you want to do on this latest version, commit it back to the central server. So this was a very tedious process, and it was giving some lock-ins. Like if a person is working on a file, another person could not work on that file. So these kinds of locking was there. So then came the third generation version control systems, which is distributed version control system. So there was now there was no central server. Every single developer or client had their own server. So every developer had their own server. Basically, your machine is your server. You can say your machine is your server, and each developer had a copy of the entire history or version of code and all its branches in the local server. So everyone had their own version of the code, so they can now go ahead and make changes, test out, commit locally, and finally when they are like that, now I have built a full-fledged feature, I can push to the main remote, which is the main repository which is used as an origin. So this allowed a lot of distributed work, and it was a tremendous success. And JIT is the most popular distributed version control system we have today. So JIT is the most popular. There are a few more, but JIT is the most popular. So, so that's why we are going to talk more about JIT and what is GitHub. So basically JIT is open source distributed version control system that works on the local system. So you have to, so if you install JIT, it will work on your computer. But cloud platforms like Bitbucket, GitHub, GitLab, these allow you to host these Git repositories on the cloud and also add more features so that people can collaborate. So these platforms take scale up your Git repos. And then there are softwares like GitHub Desktop, Tortoise Git, SourceTree. These are the applications that actually ease your interaction with Git repository and platforms. So these can enable you to interact with your local repository and also the cloud repo. If you did not have these softwares like GitHub Desktop, SourceTree, Tortoise, you have to resort to CLI and command line interface. I know a lot of Linux guys love it, but a lot of people don't love it. So that's why these applications are very useful, and they ease the entire process of actually version control process and entire process of software development as such. So it is very important to understand the role of each of these components. The role of JIT, the role of GitHub. JIT, do not confuse JIT with GitHub. These are not same. GitHub is a platform. Similarly, you have GitLab, Bitbucket. These are also platforms which allow you to scale up your JIT. They take it to the cloud, host your repositories on the cloud, and they interact, and GitHub interacts with your local JIT on your system. And then there are applications like GitHub Desktop, which are actually allow you to interact with your lower Git repository and the GitHub platform repo. So now let's get started with GitHub Desktop. So what is GitHub Desktop? So GitHub Desktop is actually a really cool toolkit. It reduces the frustration and makes Git and GitHub workflows more approachable. It extends your local environment, extend GitHub to your local environment. So now you can interact with GitHub locally using GitHub Desktop. Then you have then the entire UI is so intuitive and user friendly that it prioritizes workflows for beginners and collaborative teams. So since there is no command line interface and there is no need to be an expert in the entire commands, you can use the UI to actually accomplish your entire workflow, software development workflow using this desktop. It has a variety of people using it, but the code users are developers, and it is fundamentally there to help you get your work done faster. So instead of unnecessarily spending more time on this entire maintenance of Git repository, you spend more time on developing your project and let these interfaces handle the rest of how to maintain the repository. So, and it also encourages best practices. We will see later how it encourages the best practices. So let's get started with GitHub. In case you have not yet set up your account on GitHub, we will go through the process. So the first thing is to go to the website, that is github.com. There you press on the sign up button on the top right. You press sign up. You enter your email. I'm entering a dummy email. Then you enter a password. Then you pick up a username. Pick a username wisely, because this usually a lot of open source developer are actually known by their usernames. People don't even know their real names. So pick a good username for you in case you haven't done so. Then you can subscribe or unsubscribe for emails. And then there will be a verification. Finish the verification. And then enter a code which will be sent to you over email. So you receive an email, you enter the code, and you are ready to go. So this is the GitHub that you will see once you log in into your GitHub account for the first time. Now the next step is to actually get started. So the first thing that you need to do is configure your GitHub desktop. So in case you have GitHub desktop, go ahead and press the preferences. Go to the preferences, and in preferences, go to accounts, and in accounts, sign in. Click on sign in, and actually you have to sign in your GitHub account using this GitHub desktop. So what it does is actually it connects your GitHub desktop to the basically GitHub account. So it is important to do this step. So just sign in using the browser. Go ahead, sign in. You authorize the desktop application. So this will authorize the application to actually use GitHub. Now the next step is to select an editor that you want to use. In my case, for example, I wanted to use Visual Studio Code, so I selected it. There is also option to select Xcode, Android Studio, any editor that you think is right for your project. Select the editor over here, and the most important part is set up your Git configuration locally. So what GitHub Desktop does is it also, in case you don't have Git installed in your computer, it will also automatically install it for you. So all you need to do is just set up this configuration. So in this configuration will be the same. You have to enter the email that you used for the GitHub account, and a name that you selected for your GitHub account. So this will so now your setup is complete. You have your GitHub account ready. You have your GitHub desktop set up. So any other question, any questions so far? Anybody is having any difficulty? We will just take a minute to check if everybody is done with this step.
Sign in to our personal email.
Yeah, you can use a personal email. There is no problem.
Okay, sir. Okay.
Yeah. It is your account, your repository. You can use any email that you want. Just
okay,
make sure that email stays with you, because at times they will send verification codes if you like use it in another computer. So if you lose access to that email, then it will be difficult to retrieve your account.
Okay, sir. Understand.
Sir, can we use student email?
Do you guys have student email valid even after college?
No, sir.
Then why will you use that? Because then you won't be able to sign in later on after you leave college. because if you'll get a new computer, it will ask for a verification code, and then you will not receive the code because you don't have access to the email. Make sure you use an email to which you have access throughout your life. Any more questions? Has everybody finished this setup so far? Anybody is having any issue? So guys, quickly raise your hands if you have finished setup so far.
Excuse me, sir.
Yes.
Uh, can you please once again tell us what did you do after the sign up?
Yeah, sure. So let me go back. So after I did a sign up, I actually opened the GitHub desktop on my computer. So it will look something like this. The first time that I open the GitHub desktop, it will look something like this. So I will find, I am using Mac OS, so the preferences is given over here. But in the file menu, you will find preferences somewhere in the Windows in case you are using it. So you have to select the preferences, and in preferences, it will show you this dialog box. In this dialog box, you have to connect this desktop. So right now this desktop is just installed as a software. You need to connect your desktop to your GitHub account so that it knows that you are the one who is operating this GitHub desktop. So click on sign in, and then you continue with browser and you sign in using your GitHub account that you just created. After you did this sign in process, you do authorize the desktop to actually use your repository. You can again go back to that dialog box, click on integrations. Earlier it was accounts, now we'll click on integrations. You can select the code editor that you want to use. In my case, I'm using Visual Studio Code. I also have Android Studio and Xcode available. So people might want to use PyCharm or any other Sublime Test or any other IDE. So select the IDE of your preference that you want to use over here in the integrations. And the last most important thing that you need to do is configure your local JIT. So what GitHub Desktop does, it installs in case there is no JIT installed in your computer, it will also install JIT in your computer. That is used by GitHub Desktop. So so you need to configure the JIT. So in the JIT, you actually enter the same email that is configured with your GitHub account. So the email should be same across so that it knows that, okay, this is the JIT repository belonging to this user, which is belonging to this GitHub account. So everything is now connected. So so make sure you have this email same as your GitHub account, and then you save it. Once you save it, you are done. So any doubts in this part?
Hello.
Yeah, any doubt?
Yes, sir. Can we change all the integrations accounts? Sorry, accounts, not accounts, integrations.
Yeah, you can change that. No issue with that. You can change it at any
Okay.
time. Yeah, you can also change it later. No worries. These settings are also not final. You can also change the JIT settings account. You can sign out and sign in using another GitHub account. So it's not that it's not foolproof. Like once you just set it once. But right now, if you're setting up, just make sure you do these settings so that you can proceed further and you can actually receive no errors and all when you are doing the exercises. Anyone having any issues with this so far?
So what we do in specific feature section?
Can you please repeat?
There is a specific feature section.
Uh, where is it? Just a second. Is it on Windows?
Yes, sir.
Yeah, basically, not all the things are important. Just right now, just make sure you have these three things in place. Rest will follow. You can tinker around with it later, no worries about that. But make sure your JIT, most important is your JIT should be the same email and your account should be connected to GitHub. So make sure you do these things right now, these two things. And in external editor, you can select any editor of your choice.
Okay, sir. Okay.
Yeah. Any issues, guys? Any more doubts so far?
So what to do after getting let's get started?
Where is let's get started? Yeah, over here, right? Did you go to preferences?
I'll see, sir.
Yeah, in the menu bar somewhere there will be preferences. If you are using Windows, there will be preferences in some menu option. Just check for preferences, and once you press preferences, you can connect your github.com account, sign in using github.com account, and then basically after finishing that process, select your code editor using integration, and then using JIT, select the email address, which should be same as your GitHub account. This email address of this JIT should be same as your email address of GitHub account. Make sure you do that.
So there's only create repository option.
No, that is on the desktop, right? On the top in the menu bar, there is some preference over there.
Actually, sir, on Windows, I guess it's not preferences, it's options. You can
Okay.
just check. Yeah.
Then please, whoever is doing it on Windows, just please share it with everyone. What is the place that they need to select? It will be a good idea. If you can also post in the group a snapshot, it will be really good so that people can quickly click on that.
Yes, sir, found it. It is in the options.
Okay, can you post an image in the channel so that others can also follow, in case they are still wondering where to find the options.
Where we get the get started option?
Yeah, someone just said it's in there in the option. I'm just waiting for the image. Then maybe I can share it on the screen. Yeah, I'm just sharing my screen. It is over here in case. Yeah, if you click on File, click on Options, you can see that screen. File and Options. Then you will have all the options that I just mentioned. If you are using Windows, click on File and Options. Yeah, someone also shared it in the channel. Thanks Tushar for sharing it. So we will move ahead. In case you are having issues, just try out this part. And since you have to cover a lot, let's move ahead. So the first thing is actually to before creating a repository, the first thing we should do is actually go ahead and view some repositories. See how actually people build open source projects, how they structure their projects and all. So to view a repository, the thing that you need to do is basically if a repository already exists on a remote, like if it already exists on github.com, you can create a copy or clone of the entire repository or a branch within a repository to your own machine using git clone command. So in case you are using command line interface, this is the process that you do. If someone asks you an interview, actually you do a git clone command and you clone the repository. Now it is typically done only once at the beginning of your interaction with the project. What it gives you is the ability to work freely as you are not limited by which files you can work on. So you can access the entire repository, all the commit history, all the branches. You can view the code base, the repository structure, code structure, make some minor local changes. You can tweak around the code, run it, and you can learn quite a lot from that. So to view a repository in GitHub desktop, what you need to do is go to a repository. For example, this is I'm selecting a light repository which I built. So it is github.com/animator/titus2. So I selected this repository. If you try this out, then it will quickly, you can quickly clone this repository. Just click on this code button over here. And after you click on this code button, you can see there is an option written as open with GitHub desktop. So click on this open with GitHub desktop. And finally, you can see that in your GitHub desktop, you will get this dialog box. Now in this dialog box, you can actually go ahead and you can see the URL of the repository, which in this case is github.com/animator/titus2 and the local path. Now you can edit this path also as per your convenience. You can specify the local path. Click on clone. When you click on clone button, it actually clones the entire repository. It will be a quick process. Quickly you can clone the entire repository. And this is the interface that you will have in front of you. So guys, have you finished this cloning part? Let's take a minute to quickly get in pace and clone a repository. Anybody is having any issues cloning any repository? You can use this repo for cloning purposes. It is a quick, small repository. It will take very less time. Okay, so now let's continue. So once you clone the repository, you can see this top left, you can see current repository is mentioned over here, which is Titus 2, the repository that we just cloned. You can click on that button and it will show you that right now there is only one repository added to your GitHub desktop. Now you can also view, you can click on this current branch, which is master, and you can see that currently there is only one branch in this project. And also there is a very important button over here, which is which right now I'm pointing at, which is fetch origin. So what it does, every time you clone a repository, you clone it till that moment of time, like all the commits till that moment of time. Now the next time you open your desktop, GitHub desktop, it is recommended that you fetch origin so that the latest commit that has been done on that repository is also committed to your local repository. So it is a very good practice to actually fetch origin like once every day. It is if you are using if you are opening up some exploration work, you can fetch origin every day so that it syncs up any recent commits that has been made to that repository. Now, once this part is complete, you do the fetch. You have synced the local repository, cloned the repo. Now the most important stuff is now you want to view it. So you can click on this button called is Open in Visual Studio Code. So whatever editor you select, it will be written open in that editor. So just click on this button and the entire repository will pop up on your computer editor. So you can see the entire code base right now in your editor. You can check out all the files, how the code structure is there, what all test cases are there, how the architecture, what is the architecture of the code. So you can view the entire repository and learn a lot from this process. So this is a good starting point to actually start your open source project, which is by looking at other open source projects and what are the practices that they follow. Now you can also click on this history over here. So there is changes and there is history. So since you just cloned a repository, you have not made any changes. So right now there will be no changes shown over here. In the history section, it will show you the entire history of all the commits that has been made to that repository. So you can see the entire history. You can see, OK, in the last commit, what all changes were made. You can directly view it in your GitHub desktop. So all the changes are now visible to you. Now, this coming to the second important part, which is creating a repository. This is where your open source journey will actually begin. Now, to create a repository, if you are making a new project, usually you use the git init command. So in your local computer, in your local desktop, when you execute this command using command line interface, then it turns any local directory into a Git repository. Now this Git init, if you pass a Git init directory, then it transforms a directory in the current path into a Git repository. So this is how you do it using command line. But in desktop, you can easily do it by clicking on a few buttons. So in case you don't have any repository in your desktop so far, then you just click on this button, which is create a new repository on your hard drive. In our case, since we have already cloned a repository, so what we can do, we can click on the top button, which is current repository. Click on that add button, small add button over there, and then click on create a new repository. So once you do this, it pops up this dialog box. This dialog box is where you mention the name of the repository and the description and the licenses. So for example, I want to name the repository as repo1. The description is basically I want to do some basic mathematics. I want to write some basic maths code, and I set up a path that, OK, this is the path where you should initialize this repository. Also, I tick mark that initialize this repository with a README file. So it will automatically create a README file for me, and I can select a license. Now these licenses are basically open source licenses. So different licenses come with different caveats. So for example, some licenses are like if you use this open source software in your open source software or in your any software, then you have to also open source that software. That license is GNU GPL v3 license. That is like copyleft license. Like if you're using my software which is open source, you also have to build something which is open source and you have to open source that software. Now the most widely used software is like MIT, widely used license is MIT license. In MIT license, there is a lot of permissions, like you can use it freely, you can use it for commercial use, you can use it for open source use. So usually people, open source folks are like, they are like, no worries, just if you are happy using my software, you go ahead and use it in a commercial software. We don't care. So a lot of people select the MIT license for that purpose, and we will do the same. We don't care whether or not the code base that someone is in which someone is using our software is open source or closed source. So we'll select MIT license and then hit on create repository button. It will quickly create me a repository, a local repository. And you can see now the top bar has changed. Now we have current repository set as repo1, current branch set as main, and publish repository option is there instead of fetch origin, because right now this is a local repository, Git repository on our hard disk. There is no GitHub involved right now. It is on our hard disk. So whatever you are doing right now, the version control that you are doing will be local. You are not open sourcing anything. So it is a very good practice to actually start here, because here once you reach a certain maturity with the project locally in your hard disk, then it is a good idea to actually release it on GitHub so that others can try it out. There is no point publishing us incomplete software on GitHub right now. So once you develop some piece of code locally which can be reused by people, then you go ahead and publish it. But right now you use this local repository. So far, so yeah, you can next you can check out the history. You can see the initial commit. Initial commit includes the license, which is automatically generated, which is a MIT license, and a README file, which includes a description that we mentioned in the repository description. So some basic math code we mentioned in the description of the repository. So that is also mentioned over here. So it is important to understand that this is the initial commit. It comes with a license and a README file. So any doubts so far? So in case you haven't viewed or cloned any repository, you can also quickly jump to this step and complete it. Any doubts? Anything, guys? Anybody is facing any local repository issues? Creating a local repository, any errors, anything? Okay, a quick raise of hands. How many of you have completed this step so far? Please quickly raise your hand. Okay, we have Arvind. We have Abra. So those who have not yet completed this stage, please let me know so that in case you have any doubts, I can quickly tell you what to do. Any doubts, any questions, please throw it around me. Type it on the channel anywhere. Okay, I will just type the repository, which you can go ahead and clone. So you can quickly click on this repository. I shared the link, and you can quickly go ahead and basically clone it by. Yeah, just click on this code button over there at the top and open with GitHub Desktop. If you click on code and open with GitHub Desktop, it will automatically clone it. So you can adjust the path, local path where you want to store it, and just press clone. So it's a very simple process. You can just complete this process and it is there. Now you have the cloned repository on your disk. Now you can just click on this open in Visual Studio Code or any other editor that is shown over here, and it will open the entire code base on your editor of choice. So if you have any doubts in this stage, please let me know. Yeah, Vishnu, if you have any doubts, please let me know. It's a very straightforward process. You go to code, open in GitHub Desktop, clone the repo, and you are done. Open it in Visual Studio Code, and you are done. You can now view the code. Great. So let's move ahead. So after cloning, creating a repo is very straightforward. You create a repo, assign a name, a short description, and it will create the repo as I shared. You just create a name, name of the repo, description, initialize it with a README file, select a license. I'll select MIT license, and it will create a template repo over here. Now the next step is actually, now you can also see that there is only one branch, which is main. Now let us go ahead and do some editing work, because right now it's just a blank repository. Let's do some editing. Let's add something. So let's open it in Visual Studio or any other editor of choice by clicking on this button. It will open up the repository. As you can see, there is license file, readme.md file. So let us make a very small edit. I will just edit some basic maths code to a collection of some basic math function. I'll make a very minor edit. So once I do Control S, you can see that in VS Code there is a small m over here. This M indicates that you have modified the file. So this will kind of tell you that, okay, this is a file which you have modified in this right now when you made the changes. Now, once you click this, there's a top new file button. You can click that button. Then you can create a file known as basic underscore fns.py. Let us create this file basic underscore fns.py. It will show a U over there. This U means that it is untracked because right now there is no basic underscore fns file in our repository. There are only two files in our repository, which is license and readme. So we create a new file which is untracked by our Git repository right now. Let us add a very basic function which is def add to within brackets a comma b. This is a Python function, a very basic Python function which takes two arguments a and b and returns the sum of a and b. Once we do this, we save it, and after saving it, let's close the Visual Studio Code. So after saving it, we can now go back to our GitHub desktop and we can see that there are two changes in our repository. The first change is that readme.md file has a yellow square box and a dot. This means that this file has been modified. And there is another file that is basic underscore fns.py, which has a plus sign inside a box, which means that a new file has been added. Now you can see in this new file, all the lines are green in color and there's a plus sign, which means these are the lines that have been added in this file. And in the readme file, you can see there is a red line, which has a minus sign, and there are two green lines which are in plus sign. This means this line with minus sign has been removed from this file, and these two lines, which is a new line and a new line which is a collection of some basic math function, has been added to this file. So over here you can quickly see how easily you can see what are the lines that has been removed from the repository, the lines that have been added to the repository. You can quickly view all the changes that you have made so far in your repository. After we make these changes, now the thing you have to note that these are unstaged changes. So till now the changes that we have made has not been committed to the Git repository. Right now it is just unstaged. You have made some changes and you are still deciding whether or not you want to go ahead with these changes. So it is made in the current working branch. Now, the whole purpose of this is you want to shape the changes made to the Git repository. So if you're using command line, you have a git add command, which actually allows you to select the files that you want to bundle together to address an issue or a feature or an idea. So we are human beings. At times we work on 2-3 problems or issues and end up saving multiple files. For example, we might do some documentation edits. We might do a couple of bug fixes. So all these things basically these changes may not belong to a single logical group or idea. So there might be multiple groups and ideas and commits. And that's why commits have two phases. The first allows you to select the files that have a same idea, feature or issue. And then it puts them in a staging area. And then what git commit does, it takes these files in the staging area and creates a commit, which is like a snapshot in the repository that, okay, this feature was addressed using these all files. So you have to note that git add and git commit always go together. You cannot do git add multiple times and do a git commit and basically think that the multiple times you did git add will be added individually. No, you have to do git add, select the files that you want to stage and then commit those files. So they go together. So GitHub Desktop helps us with that process also. So over here, I can just select the file I want to use. For example, I want to just commit the README file. Right now, I'm not sure about the function that I wrote. So I'm like, okay, I've modified the README file. It looks good. Let me go ahead and commit it. So I will select the README file, readme.md. Then I will go ahead and add a description. For example, I've added a description. You can see that I have modified the description of the project. And then press the commit to main button. Once you do this commit to main, you can see now there's a new commit on your repository, which is only the README file that I committed. So you can see that I had an initial commit. I made a few changes, but I said that right now I just want to go ahead with the changes I made to the README file, and I will go ahead and commit only the README file. So what it does when I select the README file and press commit, it adds the README file into the staging area and then commits it in the repository. So this is a very conceptual part. So anyone who is having any doubts, please now is the time. Ask your doubt. If you have any doubt regarding this part, staging and committing a file, please let me know, because this is very important when you are doing project development. Okay, so let us go forward. So the thing is, now we are done with cloning. We are done with initializing, that is Git init. We are done with that part using the UI. We are done with adding Git add, Git commit. So we are we are done with these important concepts. So till now, but you have to understand, all the changes that you made are in your local computer. It is still not published or open sourced. It is not published on any platform like Bitbucket, GitHub, or anywhere. So the next important step is to actually go ahead and publish your Git repository. So now we will learn how to actually open source the project. So to take this local repository public, one requires a remote URL where the code is stored. So in this case, that URL will correspond to the repository on GitHub. So right now the URL that I shared of a project in the Discord channel is the URL of a project that is hosted, that is the remote URL, and it is hosted on GitHub. So what we need to do, it's a very simple stage. Just we need to click on this button, which is publish repository. Once we do publish repository button, what it does, it creates a remote repository on github.com. It adds the remote URL to the local Git repository using this command. So if you are using command line, this is how it happens in the command line. But in UI, this is what happens in the backend. All local commits are pushed to the remote, which is the GitHub repository. All the commits that you made locally are now pushed to the GitHub server using git push u origin main. So so right now, when we do publish repository, it will ask us that do you want to keep the name of the repository as repo1? We will name it as repo1. We will add a description for GitHub. In GitHub account, there's a description. We will add the description and we will quickly click on publish repository. Now, once we publish the repository, you can go to your GitHub account and you can share your repository over there. So you can quickly view the repository over there in your GitHub account. Under the repositories tab, you will have your repository listed. So anyone so let's take a minute. Once you do this part, please post the URL of your GitHub repository in the Discord channel. So so that in case people have any doubts, they can also ask you how you did it in your desktop. So in case you have done it, just post the repository on your GitHub account so that people know that, okay, you are done with the step. They can also reach out to you for the same, since we have very less time. So let's continue. So once you click on the repository name, it will show you all the things that you did, the two commits that you made, the README file, the license file. It will show you these files and you can quickly go ahead and actually click on this two commits written over here, the commits written over here, and it will show you the exactly same commits that were there on your GitHub desktop. So it is quite simple. You can click on the commits and view the commits. So now it is synced. Now whatever you had locally, it has been published globally. You have now put it on github.com. You have started your open source endeavor. Once you do that, you can also click on each of the commits on github.com. In the website, you can quickly view all the commit changes made to the commit. It is quite straightforward there. Now over here, that publish to repository in the desktop will be replaced with fetch origin. So now you have to understand that the repository hosted on GitHub is different from your local repository because anyone can contribute to that repository since you allow collaborators, right? So whatever changes are made to GitHub repository need to be synced with your local repository whenever you think that there are any contributions made to the github.com account repository. So this button allows you to sync your local and actually the GitHub account repository. So now let's go ahead and commit the second function. Uh, Add to function. Let's go ahead and commit it. Once we commit it, we can push it to origin. Origin is basically my github.com repository. I'll push it to origin. All my commits will now sync to the local, and this will sync with the github.com origin repository. So if you go to the account in the repository, you will see a new commit over there, which is create file with math functions. So this is the new commit that is now over here, and you can view the code over here also. So you can see how easy it was to actually create a local repository and then take it and publish it on github.com using this GitHub desktop. Now the next important step is actually to understand that there is another way to do this entire task, which is the remote first approach. So instead of creating a local repository, another thing you could have done is directly went to your GitHub account, click on this new button in the repositories tab. Once you click on this new button, you can it will ask you all the details like the name of the repository, description, whether it's a public repository or private. You can add a README file, choose a license. So in github.com, you can directly enter these details and it will create a remote repository over there itself. So what you can do, you can quickly, once it is created over there, you can click on code button. You can see that a remote URL is assigned, which is superpunk/repo2.jit. You can click open with GitHub desktop. And what it does, it actually you can now clone your own repository and actually make changes locally and sync it with the remote. So over here, you just clone it and you're good to go. Now there are two ways. First you created one in hard disk and then you published it. And another way is when you start directly a repository on github.com and you clone it and then you commit changes here and then you sync it with the origin. So these are the two methods in which you can create a new repository and start your open source project. So after doing this, let us go back to repo1 because the repository name was repo2 over here. So far, any doubts, guys? Anyone? Any doubts? Any step that you missed, you want me to just go through it once more so that you can try it out? Any doubts? Anything? Okay, so let's go ahead. So the next part is basically once you go back to repo one, you can open the repository using this menu bar. You have this menu bar. There you click on repository. You can open in Visual Studio Code. Once you do that, what I want to do, I want to add another function, which is def add 3. What this function does, it takes 3 arguments, a, b, and c, and it returns the sum of a, b, and c. So once I do this change, I save it and I close it. So now I have the modification over here. Basic funcs has 3 new lines, a new line and a line containing the function definition and a return statement. So you have to remember that not all changes that we do might be desired. So what are the different ways in which we can undo these changes? So the first thing is, if you want to directly discard any changes made to a file that you made by mistake, or you think these changes are no longer required, you can directly right click on that file over here and click on discard changes. Once you do discard changes, it will actually send this file to the trash, and it will restore the original file which was there. So it will so now click on discard changes and it will remove the changes. So now the file that you have in your repository is no longer affected by that change. So this is a very quick method of discarding any unwanted change. Now the next step is if you have any unpublished changes. For example, if you selected a few files and you pressed commit. For example, let me just add a description for this change that I did. For example, I added add 3 function. So this I can commit this file, and now I've committed it, and I have not pushed it to the origin. So you have to remember, right now the change is committed only to the local repository. And now I want to remove this commit. I don't want to commit it because there might be a case where I forgot to add one more file to this commit. Or there might be a case that there is some minor mistake which I did that I want to basically redo and again commit. So you can right click. So basically there are you can just quickly go to this main screen. Over here you can see at the bottom there is an undo button there. So what this button does, it undoes the most recent commit. So whatever commit you made recently, it undoes it, and it will actually it is equivalent to git reset mixed head one, which is that it will undo the last commit that was made. So what you do is basically again you revert back to this stage where it is showing that okay, this file has been modified. Do you want to go ahead and commit it? So even if you commit by mistake, you can actually undo that commit. So once you do that, you can see that the commit is no longer shown over here. So if you go back, there was a commit over here, which is update basic underscore functions. You can see there was a commit, but now that commit is no longer there. So, but this is only for unpublished changes, the changes that you made that has not been sent to github.com. So what in case there is a commit that has been published that you want to revert, then the command is git revert. What it does, it is a forward moving undo operation. Let us look what it does. So for example, let us commit the same file, push origin. Basically now it will push all the commits to the remote server, and basically you can go to the GitHub account. You can see, yeah, the commit is reflecting on GitHub. We added a new function. You can see the function. Now what I can do is I can select a commit, right click on it and click on revert changes made in the commit. So revert changes in commit. Once you click on this, then what it does, it just reverts whatever changes were made. For example, I added 3 lines in this commit, it automatically reverted and removed those 3 lines in this new commit. So this is a forward moving undo action. So this is very important because you don't once you publish it online, once you publish it in GitHub, there might be people who are using that basically repository. So you should not actually remove or take back certain commits. So because people might be dependent and based their software on those basically commits. So it's always a good idea to actually forward undo action, which is you say that okay, in the next release I am reverting this commit so that they can also sync with those commits in the next release. So always once you publish it, the only recommended way to undo any commit is to use this git revert method. Now you can go ahead and push this new reverted commit to the origin. So now you can see that okay, you did an update and you also reverted it. So in the github.com repository, you can see that you reverted it. So it is forward. So the repository is moving forward. It's just that any action that was done in one commit has been reversed in the next commit. And now coming to the final part, which is how to actually go ahead and contribute to an open source project. So how you can do that is basically this is the workflow. First, what you do for your GSOC and all, you should raise an issue in GitHub project page and discuss. So if you say that you want to develop a feature or you want to actually go ahead and contribute to a project, then you should raise an issue in the GitHub project page and discuss it with the maintainer. So in the issue, you will discuss that, okay, I want to do this. Is this the right way to do it? He will say that, okay, no, this is not the right way. You can do this. So you interact with and discuss. Now fork the repository. Then after deciding that, yeah, this is what you want to do, you will take take it forward. Then you fork the repository to your personal GitHub account. Now you clone this forked repository onto your computer. Then you create a new branch to work on the feature or bug fix. Then you make changes to that code in that branch. You test your code. Then you commit your changes and push it to the remote forked repository. So your repository, you'll push it back to your repository on GitHub. Then you open a pull request and submit the change that you made in that fork. And then wait for the maintainer to review your work. So once the maintainer reviews your work, he will go ahead and if your work is satisfactory, he will go ahead and merge your pull request into the original repository. So this is actually how you contribute to an open source project. So this is how the workflow looks. It starts with creating a branch, making changes, creating, submitting pull request, discussing, and then finally merging. So let us take an example. The same repo one that I took. I will go ahead and create an issue. Now, right now I am a user. I'm another user. I'm using my personal account to actually go ahead and create an issue. So I will say that I want to add a new function which sums up all the numbers in that argument. So I can supply any number of arguments and it will create a sum of those arguments. So I make this proposal. I can preview it. Now I submit a new issue and then I wait for the maintainer to actually comment. So the maintainer now reaches back to me. He says that, hi, sure, have a look at our contribution guidelines. So in case they have a contribution.md file, you need to take a look at that and then feel free to send a pull request. So now next step you need to do is go ahead and fork this repository. So over here you can see there's a button which is called as fork in the top right. Click on fork. It will start forking the repository to your personal GitHub account. Over the top you can see now there is a new repository which is animator/repo1. So it's a fork of the original repository. Now I will click on code I will click on open in GitHub desktop. I will basically it is simple cloning. I will clone it on desktop. Now it will ask me whether what is the purpose of my project. Am I doing it to contribute it to the original project, or I want to start my own fresh project from here. So right now what I want to do is I want to contribute back to the original project. So I will select to contribute to the parent project. Once I do that, it will open up the repository. You can check out the branch. It is main branch. The next step is to actually create a new branch where we will add that feature. So click on new branch. Write a name of the branch. For example, I want to add an add all feature. So I will write add all dash feature. I will create a branch. Now you can see on the top, the current branch is now add all free feature. So now in this branch, I will make all the changes that I want to do, and then I want to commit it back to the project. So now the step is straightforward. I will open the code in Visual Studio. I will write an add all function. This is the function. It's a Python function which actually takes any number of arguments and it adds it. I will go ahead and write a description, summary and description. I will click on commit. You can see it is now committed. And you can see a new user is there. Earlier it was the original user. Now I am committing, making the commit. So it is under the name of it is under my name. So now I will go ahead and publish the branch. Once I'm satisfied that, OK, this feature has been fixed. I have made all the commits required for this feature. I will go ahead and publish the branch. After clicking on publish, GitHub Desktop will automatically tell you whether you want to create a pull request. So just click on create a pull request. So what it does, it automatically opens the browser. And over there you can describe that, OK, you have added this function. This is what you have done and the issue number that it is addressing. So for example, if you write closes issue number 1 or resolves issue number 1, then it will automatically link this pull request to the issue. So we will also see that. So I'll write closes issue number 1 and you can see the changes that I made. So I added this function. Now I committed it. I submitted the pull request. I submitted the pull request. So now if you go back to issues, you can see that there is a milestone. There is one link pull request written over here. Since I mentioned closes issue number 1, it's a keyword. Closes is a keyword. GitHub automatically assigns that pull request to the corresponding issue. Now I can click on it, issue, and you can see that that pull request has been added to that issue. You can see that the pull request is now submitted here. Add all function added. Now coming to basically from the maintainer perspective, if I'm a maintainer, I will see this in my dashboard, issue dashboard. Once I open the issue, I will see the pull request. In the pull request, once I open the pull request, I will see that, OK, a person submitted the pull request, the changes that he made. So I can see the commits, the changes that he made. If I want to add any comments that, OK, this is not how you should do it, this is how you should do it, then you add your comment over here. Once you add your comment, you can actually let him commit, make more commit changes and then send add to this pull request. Or if you're satisfied with these changes, you can go ahead and create a merge commit. So what it will do, it will merge this feature to my main repository. So this is the final, like you will say, it is like the best feeling you will get is when someone merges your request or your issue resolution or your bug fix to the repository. Then you are actually counted as an open source contributor. Once you get a pull request, they are like you are officially added as a contributor to that GitHub project, and you can actually go ahead and write it in your resume for now. So make sure you contribute it. You send in a pull request, discuss it with your maintainer, resolve all issues, and then make him basically make him approve the pull request. If it is totally correct and correctly implemented, he will maintainer will go ahead and say that okay, I'm merging your pull request, and once it is done, you are officially added as a contributor. So now you can see the user merged the commit to this main repository. Now automatically GitHub determines, because I linked it with this pull request, it automatically determines that the issue has been resolved. So you can see that now there is no open issues. If you go to closed, you will see that the issue has been closed. And you can also in the commits, you can see that my commit is also now added to GitHub. So in the main repository, my name is also there. You can see add all function has been added. So once this entire process is successful, now coming back from the contributors perspective, I no longer need this branch. I will just go ahead and delete the branch. I will close the since the pull request is closed. If I don't need to contribute to this repository anymore, I can go ahead and also delete the repository. So you can go ahead and delete the repository. And once you do it, it will ask you for the repository that you want to delete. And once you understand the consequences, you can delete the repository. It is not required to delete it because you want to further contribute to the project. But in case you are wondering how to do that, this is how it is done. So this is how we actually went ahead and saw the entire workflow of how the contribution works, so that you can get started with your GSOC contributions. And so if you have any questions, you can post it on the Discord group. We can also discuss it right now. There's a Linktree link, and over here where you can connect with me over social media. And I'm also sharing a link for a product that I'm currently building with my friends. So it is to actually help you guys out with resume and internships and basically learning more skills. So in case you are interested in improving your resumes and other stuff, you can sign up for the beta app, and I will as soon as it is launched, I will send you an invite. It will be a free app, no ads, nothing. So and I will very much look to your feedback. So I've shared the link in the Discord group. If you are interested in improving your resumes and learning some more skills, make sure you sign up for the beta, and just go ahead to the Discord group and you can check out the link. It's a very simple Google form. And in case you have any, you want to reach out to me personally, you can go to this Linktree URL, and you can connect to me with me over LinkedIn, Insta, Facebook, everything is over there. And right now, let's open up for Q&A. If you have any doubts, now is the time. Let's have a chat. And yeah, I'm handing over the mic to you guys now. Hey guys, any questions? Not just regarding GitHub, anything related to your basically open source journey, anything regarding GSOC. If you have any questions regarding any of the things that I covered in this session, please go ahead and ask me. I'll be happy to answer it. Also, this Discord channel will be alive. So in case you have any doubts, today, tomorrow, day after tomorrow. Whenever you have any doubts, you can feel free to message in this channel. This channel is exclusively for IEEE UK, you guys. So if you have any doubts, anything, this meeting is being recorded, so you can also, I guess it will be shared with you later. So if you have any doubts, anything, you can go ahead and post in this group, post in the channel. And if you want access to the beta app to help with your resumes and skill, you can sign up for the form, and you can connect with me on LinkedIn and all using this Linktree URL. So in case there are no questions, I guess I'll give back the mic to the organizers.
Thank you so much, sir, for such an insightful and enlightening session. I think, I hope there was a lot many things for the audience to learn today. And now it's the floor for this audience to have questions. If you're having any questions, you can ask to this, sir.
Yeah, if you have any question, ask it, post it on the channel. Feel free to ask me anytime. No worries. You can connect with me on LinkedIn and ask me.
Okay, sir. Okay, sir. So, friends, you can ask with sir on his channel. So now I request everyone to switch on the cameras for having a group photo.
Thank you, everyone. We are done with the group photograph.
Thank you, sir. Now we would like to present a small token of application to you, sir. Ayush, can we have the virtual play getting presented, please?
Thank you, guys.
Again, I would like to extend my heartfelt gratitude, sir. I also would like to thank all the participants for joining us today. It was really wonderful to have you all here. And now, with this, I would like to close today's session. Again, thank you for joining us today's session.
Bye, everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.